In this video, we're going to look at the graph of a sine n theta. Now, what could that entail, a sine n theta? It could just be the sine of 2 theta. It could be 4 times the sine of theta, or it could be 4 times the sine of 2 theta or 3 theta. Probably a lower number. It's not going to be sine of 25 theta. And we're going to look at how we create these graphs. So let's start with this one, the sine of 2 theta. So y is equal to the sine. Actually, let's start with y is equal to 4 sine theta. Y is equal to 4 sine theta. Now, if the angle is just theta, the period will not change. The only thing that changes is the range. So this will affect the range, and this will affect the period. So the period in this case is still 2 pi. I'm just going to jump off to the side here. The period is always 2 pi over c, where c is this number here. So in this case, the period for 4 sine 2 theta is 2 pi over 2, which is equal to pi. So that means one full revolution, and we're going to see that in this video, will take pi, or 180 degrees. So let's look at 4 sine theta. I'm just going to graph it from 0. Make that a bit straighter. Now, it's the same graph as sine theta. The only thing that changes is the range. So if you imagine when we had y is equal to sine theta, the range was -1 to 1. Now, multiply each of these numbers by 4. We're going to get our new range of -4 to 4. So this number is 4. This number down here, approximately here, is -4. So that's my range, and nothing else changes. So let's fill in these values along the graph. You can see here how many sectors am I dividing. These are all equal sectors. I have 4 equal sectors, and my period is 2 pi. So if you divide 2 pi by 4, you get pi over 2. So 4 pi over 2 is 4 90s is 360. So you can see I'm going to just change the color. This is 2 pi, 360. This is 270, or 3 pi over 2. This one here is 180, or half of 2 pi. And this one is pi over 2. So you can see here the only thing that has changed are the 4s that were 1s are now 4 and -4. So this is the graph of 4 sine theta. So that's this one done. Now let's look at the graph of sine 2 theta. So let's have a look at the graph of y is equal to sine 2 theta. Now, there's no change in the range here. The range is going to be +1 to -1, or -1 to +1. So if we just graph this, the first thing I want to do is find the period. 2 pi over c, and we've done this already up above, is going to become 2 pi over 2, this number 2, which is equal to pi. So one full revolution will be between 0 and pi. So let me do 2 full revolutions here. I'll just extend my graph out a bit. Now, let's put some values on here. Your knowledge is that one full revolution, we start here, that's one full revolution, is pi. So 2 full revolutions up to this point is 2 pi. So now you should be able to see how many even sectors we've divided this in. From the start to here is 1, up to pi is 2, up to here is 3, and up to 2 pi is 4. So divide 2 pi by 4, and we're going to get pi over 2. So now each one of these dots is pi over 2. So this one is pi over 2. This one we've pi already. This one is 3 pi over 2. What would halfway between 0 and pi over 2 be? Pi over 4. Halfway between 90 and 180 is 135, or 3 pi over 4. A little bit sideways this one, but it's only a sketch. Halfway between 180 and 270, 225, 5 pi over 4, and you can see what's happening here. We're going pi over 4, 1 pi over 4, we're getting 2 pi over 4, 3 pi over 4, 4 pi over 4 for pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2. So then we're going to have 7 pi over 4, which is 315. So this is a sketch of y is equal to sine 2 theta. The only thing we haven't put on the graph are my values here. And your knowledge is that the range, or the range, yeah, is not going to be affected because we've no number in front of sine, like the previous graph. So from 1 down to -1. So this is the graph of y is equal to sine 2 theta. And it's in the domain where theta is less than or equal to 2 pi, less than or equal to 0. You could be asked to graph these from negative values. I'm just focused on positive values for this videos. And then you should be able to then map these to the left of the y-axis if you are asked for negative values. So let's look at the third graph that we have in this video. We said we'd do 4 sine 2 theta. Y is equal to 4 sine 2 theta. And let's do this one with a negative domain between minus pi and plus pi. First thing we want to do, we want to check what the period is. It's the same as the previous graph. 2 pi over c is equal to 2 pi over 2, which is equal to pi. So this is 1 full revolution. And this graph is a combination of the previous two that we've done. What's my range going to be? It's going to be -4 to +4. And let's sketch this. So I would always recommend sketching it before putting the values on, because we can just add them in. So starting at 0, 1 full revolution is going to be between 0 and pi. And then going backwards. And let me just extend out the x-axis. So let's put some values on here in red. What's this number? You're telling me it's 4. And this number is -4. Let's see how many even gaps we have. Same as the previous graph. We have 4, 1, 2, 3, and 4. And you are, that's a little bit off center. Let me just change this one here. It's only a sketch, but we should be a little bit more accurate than that one. Okay, so let's put it there. And then just extend out the x-axis again. So what value have we got here? We have pi because you've worked out the period. What have we got here? We've got, let's do it in even spaces if you want. Pi over 4. We've got 4 even spaces. So each one of these is pi over 4 now, not pi over 2. So 2 pi over 4s are pi over 2. We trade them here, 3 pi over 2. Here we have 4 even spaces. I'll do black dots this time. 1, 2, 3, and 4. So we have minus pi over 4, minus pi over 2, minus 3 pi over 4, and minus pi. So this is the graph of 4 sine 2 theta. Practice these 3 graphs, do them in your copy on a blank page, and check the video for the solution. And remember, you're only sketching these graphs. You're never asked to draw them exactly because it's very, very hard to draw the curves exactly, but the sketch will always have a margin of error. So try and get these as accurate as possible, but don't worry if you're slightly off.